Minus is a weird operation. Many think they understand subtraction, but are they really? Minus is not just an operation. Some might even say minus is not an operation at all. It is part of a number. It's a type of number. Minus is an idea. For me, minus means a negative number. More specifically, -1. Instead of saying negative number 1, which is pretty long, we say minus, because it's short and easy to understand. But is it really? Let me explain. Subtraction. When we say 3 minus 2, we all know that we get 1. But why are we doing this? Well, we might have 3 apples and we take away 2 and we're left with 1 apple. But if I want to do with other objects like books and pens and pencils and oranges, whatever it is, we can replace it by a variable, x. We all know x. Now we have 3x minus 2x equals 1x. Now we know whatever x is, we know that we get 1x. We just made it universal. That's the beauty of math, right? Negative. Let's go back. 3 minus 2. I just decided that I don't want to do subtraction. I want to do an addition because it's my favorite. Most people prefer addition instead of subtraction. I can write 3 minus 2 as 3 plus -2. Here's an idea. We are adding a positive number and a negative number, and we get a positive number as a result. This is no longer a subtraction operation, but rather addition. And 2 is a negative number because it's being multiplied by -1. Now, this looks a little more complicated than what we had initially. 3 plus -1 multiplied by 2. But nothing changed. We still get 1. We just wrote it in a different way. Did you notice that we no longer say minus or subtraction? We say negative. This is when the operation becomes a number. If we can write every subtraction problem as an addition, if negative numbers, then is subtraction really an operation? This leads us to our next idea. Addition as subtraction. This goes the other way. Let's say we have 3 plus 2, which is 5. We all know that. We can write this as 3 minus -2. We can make the same argument. Is addition really an operation if we can represent it as subtraction at any moment? But it turns out it doesn't really matter because we need both. And here's why. Since 3 plus 2 is shorter than writing 3 minus -2, with all the parentheses and all that, it's pretty much extra job to write it as subtraction. Also, 3 minus 2 is shorter than 3 plus -2. From this, you can make a conclusion that mathematicians don't like to write a lot. They like things when they are shorter and easier and faster. Yeah, which seems like the complete opposite, but we do like things to go faster. That's why we do math. Number line. We don't want to add and subtract apples and oranges all the time. That's too boring. I'm not a farmer. And even farmers, I don't think they count it like that. So plus and minus can also mean direction. If we have 1 plus 2, we get 3. On the number line, this means we start at 1 and go 2 steps forward and we end up at 3. There we have it. 1 minus 2, we get -1, meaning we start at 1 and we go back 2 steps and we end up at -1. How about multiplication? We have -1 multiplied by 2 is -2 because on the number line we have -2 here and we have 2 here. I don't know. How do we know how many steps and in which direction we need to go when it's multiplied? How can we prove that -1 is multiplied by 2 is actually -2 using a number line? This is why. Let's say 1 plus 1. It's not 11, it's 2. Using the same rule, we have 1 plus 1. We start at 1, we go one step ahead, and we end up at 2. But 1 plus 1 also means there's 2 ones are being added together. That means 2 multiplied by 1. How about -1? -1 multiplied by 2 means there are 2 -1s that are being added together, just like this. And we're going to follow the same rule because it's a rule. We have to follow it. And we start at -1. We go back one step. We end up at -2. Wow, isn't this cool? Factoring. When we have -2 plus -3, as we discussed, this actually can be written as -1 multiplied by 2 plus -1 multiplied by 3. Then if we factor out -1, because it's a common multiple for both 2 and 3, we get -1 multiplied by 2 plus 3 in the parentheses. So now, if you remember PEMDAS, we do what's inside the parentheses first, and we get -1 multiplied by 5, which is -5. This is why when we add two negative numbers, we get another negative number. This is useful when we have something like -2 minus 1, which is going to be -3. Now it seems like we are getting a bigger number when we are subtracting, but actually if we look at the number line, we see that we go to the negative direction, which is less and less. The idea is also useful when we have a little complicated problem like this. I say factor out as much as possible. First one is simple. We factor out 3x, and we don't have to worry about the signs because both numbers are positive, and we are factoring out a positive number, so we just end up with 3x, and in the parentheses what's left is x plus 2. Now for the second part, we need to factor out -2, which makes this -2 multiplied by 2 plus x. Now, a lot of people ask me when I'm tutoring, they're like, how come there's plus inside? Like, there was two negative signs, but then how come it just becomes positive all of a sudden? Now, it's because -4x minus 2x to the 2 can be written as this, like we said earlier. All we did is factor out -1. Then we factor out 2x, which means -1 multiplied by 2x is the actual factor. And we end up with the positive in the parentheses. Now, x plus 2 is equal to 2 plus x. So we factor some more and we get this. Minus as a power. We all know that 2 to the -1 is 1/2. How come? Why? This is the idea of inverse, or the opposite, or operation that undo another operation. Inverse of minus is plus. Inverse of multiplication is division. So 2 to the power of 3 is 8, because it's 2 multiplied by 2 multiplied by 2, and 4 multiplied by 2 is 8. Let's go down the steps, and we have 2 multiplied by 2, or 2 to the power of 2 is 4. And do you see that also if we divide 8 by 2 is 4, to go down the step, we're dividing, we're doing the opposite of whatever we did. That way this 2 cancels out and we have only 2 2's. So now let's keep going. 2 to the power of 1 is 2 because 2 is not being multiplied by anything, it's just what it is. Also, 4 divided by 2 is 2. Now, 2 to the power of 0, what is it? It's equal to 1. Because 2 divided by 2 is 1. So, do you see the pattern of dividing by 2 to go down the steps? Now, we're at 0, but we can still keep going because we know that there could be negative power. 2 to the negative 1 is 1/2. Because we're still following the pattern and it makes sense. And we keep going, and it's 2 to the negative 2 is 1/4. Do you see that these two sides are the same, but just flipped? Flip 4/1 and get 1/4. And if you flip 2/1 and you get 1/2. Inverse, right? Now, every time you see a negative number as a power, and you know that you can flip it if needed. But don't just mindlessly flip stuff. Only do it only when it's useful for the problem that you're trying to solve. It's like, it's like putting your pen in your bag when you know you're gonna use it in a few seconds. You're just doing some extra stuff, extra steps that doesn't help you at all. So that's all I have for minus today. That's all I had in my head. And if you want me to do more research and do more videos like this, comment down below. I don't know who I'm talking to, but probably this video is gonna get like 2 views. My mom and my boyfriend probably. But still, I had a good time doing this video, so it's good. And if you are watching this and you're trying to learn math, the whole idea of this video was that you can manipulate numbers and signs, and it's not a big deal. You can move things around, and you're the boss. You have the control, not the math. So don't be scared. Just move things around. Go crazy. This is officially the end of the video. So thanks for watching until the end, if you're still here and hearing my weird voice. But yeah, thank you. Goodbye.